All right, it's 1:01. I think we'll go ahead and get started. So welcome everyone to today's webinar. My name is Joe Gustafson. I'm the traffic engineer for Washington County Public Works, and I'm this year's chair of the CTS Transportation Safety and Mobility Research Council. A little background on the councils. The CTS councils provide a forum for transportation professionals and researchers to exchange information on current transportation issues and trends. They bring together university faculty and staff with practitioners from the public, like myself, and private sectors to recommend direction and participate in improving the center's research, education, and engagement programs. Sam is going to share a link to the council's information in the chat. Today's webinar features presentations on pedestrian safety and driver behavior near an automated vehicle. And I'll share a little bit more about them in a moment. But first, I'd like to turn it over to our council vice chair, Tara Olds, who's co-facilitating this webinar and also presenting, which I think is a first for us. So thanks for the double lift today. Tara, would you like to introduce yourself and cover some of the details on the webinar?
Definitely. Thanks, Joe. So yes, my name is Tara Olds. I'm the Director of Connected and Automated Vehicles at the Minnesota Department of Transportation. And as Joe mentioned, the Vice Chair of the CTS Transportation Safety and Mobility Research Council. Really excited to present today. We're going to give a little overview about some of the work that Minnesota DOT is doing with connected and automated vehicles. And then Dr. Nicole Morris will give a little update on some research that she's been conducting over the last couple of years on low-speed automated vehicles and pedestrian safety. So hope it's entertaining and interesting to folks. And with that, really look forward to audience participation and questions. So encourage you to raise the hand feature or type a question in the chat box. And if you have, we'll unmute you and you can share verbally if you prefer, or if you just want to put it in the chat box, we can go that route. And then just want to also inform folks that this event does meet continuing education requirements for 1.5 professional development hour credits and 1.5 American Institute of Certified Planners, or AICP, credit certification maintenance credits. So if you need a PDH form, send a chat message to all panelists with your name and email, and we will email you the form following today's event for your records. Another announcement is that CTS will hold one other webinar this spring. The final webinar will be held on May 23rd at 1 p.m. And it's titled Freight and Commercial Vehicle Safety in Roundabouts. So information on how to register is available at the CTS website, and we can put that link in the chat. That is www.cts.umn.edu/events/seminars. And then lastly, if there's any students that are joining today, if you could please send a chat with your name so we can track the number of students that are engaging in our events, that would be incredibly helpful. So thanks, everyone.
All right, thank you, Tara. I'll go ahead and introduce our speakers. But before I do that, I also want to share that Sam Honduville and James DeSoto, both from CTS, are also on today's webinar supporting the event. So to kick off our topic, as automated vehicle technology becomes more prevalent, understanding how human drivers and pedestrians interact with it is essential for ensuring roadway safety. We'll hear how U of M researchers explored this interaction on the Med City Mover pilot project led by the Minnesota Department of Transportation. The study examined real-world driver behavior around low-speed automated shuttles in downtown Rochester, Minnesota, with a focus on pedestrian safety and yielding behaviors. And we'll also hear updates on MnDOT's broader connected and automated vehicle initiatives, including the state's ongoing efforts to integrate automation into Minnesota's transportation network. So I hope you all come away from this with valuable insights on the future of automated mobility. So with that, I am pleased to introduce today's speakers. Nicole Morris is the director of the Human Factors Safety Laboratory at the University of Minnesota, a research associate professor in the Department of Mechanical Engineering, and a CTS scholar. And my co-chair, Tara Olds, is director of MnDOT's Connected and Automated Vehicles Office. Thank you, and Tara, I turn the webinar over to you now. You're on mute, Tara.
There we go. Are you able to see my screen?
Yep.
Fabulous. All right. All right, before we hear from Nicole and her research, I'm going to give a little overview of some of the work that we're doing in Minnesota, why we're doing it, and some of the things that we're hoping to accomplish. So with that, I'm going to just start why CAV, so why connected and automated vehicles. I always like to start here because I think it's a really catchphrase thing that when we say future of technology, future of the transportation system, that we can improve safety, we can make things more accessible, and we can address a lot of inequities. And we often say in the connected and automated vehicle space that, oh man, new technology is going to do all these fabulously, and there's going to be no problems. But I always note that little blurb at the end of, but only if we focus on these, because I think at the end of the day, one thing that we're finding with a lot of folks in the industry is that they're trying to get technology to work, but maybe not always focused on the outcomes that we're trying to achieve, and ensure that as we look at the way our transportation system is changing, that it's actually for the better and better for everybody, and especially better for those that have the most to gain from the changes that we can do. So I like to just highlight safety, accessibility, and equity. I think there's a lot of opportunity to do things better, to make things safer for all roadway users, particularly those that are the most vulnerable, to make things more accessible throughout the state, whether that's if you're in a rural part of the state or an urban part, whether you own a vehicle, whether you don't own a vehicle, whether you can drive, can't drive, and have other mobility challenges. And additionally, if we start to address those transportation challenges that currently exist, I think there's a lot of opportunity to address the inequities that we see within our state, and hopefully make things just better and more quality of life for everybody. So before diving into a little bit of what we've been doing within the state, I'd like to just highlight a little bit about what connected and automated technology is. You can see on the left, connected shows a little bit more about how technology is used to connect or communicate with different things, whether it's a vehicle to other roadway users like cyclists and pedestrians, vehicle to signals, understanding what the signal phase and timing is. And then we have automated, which is where you use technology or a computer system to steer and accelerate and brake with little to no human input sometimes. These are very different technologies, yet complementary. So just kind of helpful, I think, to set the groundwork of what we're talking about in this scene. When we go into Nicole's research, I will note that the vehicle that they were researching was both connected and automated, as it was able to communicate with the signals by understanding what the signal phase and timing was, but was functioning in an automated state where it was utilizing a number of different things like sensors, like LiDAR and cameras, as well as GPS and cellular technology. Little overview of some things that we're looking at within CAV at MnDOT. So we're currently working on developing a new CAV plan. It's a CAV tactical plan that falls into our PISMO strategic plan. We're working on developing 4 core areas that we're going to be focusing on, which are, you can see here on the screen: research and development, leveraging partnerships, sharing knowledge, and planning and policy. We had a previous strategic plan that had 65 recommendations, 9 different focus areas. And quite frankly, we recognize that it was a little broad, and that as we've learned over the last 5 years with work that we've done, both in research as well as testing of infrastructure and seeing where technology has continued to advance and the direction maybe has changed, that we can be a little bit more focused about recognizing where the real benefit is for our state, for our citizens, and that we have the opportunity to maybe make substantial investments and advancements in the industry. So we're really excited to continue to be working with this. Like I mentioned, we're still kind of in the development of the new plan phase. So these are draft and they may end up changing, but under each of these we'll have some key specific works that we'll be focusing on as well, that we'll be excited to share over the next year. And then lastly, before I dive into a little bit about some of our projects that we've done, that Nicole will again give a little bit more detail about with regards to the safety, is we have Minnesota CAB guiding principles. I think these are really helpful to sometimes share to a broad audience, to recognize that when we look at the role of connected and automated vehicles and the way it can potentially transform our transportation system, we see a lot of opportunity, like I said before: safety, accessibility, and equity, and we could probably list a number of other things as well. But we also recognize that we have a lot of opportunity to dive into different things, and things are constantly changing. And so how can we be strategic about that? So back in 2021, we coordinated with our our Governor's Council on Connected and Automated Vehicles, which is a body that's appointed by 15 members that are appointed by the governor, as well as our CAB Innovation Alliance, which are the working groups of the council, to establish these guiding principles that we adopted. These guiding principles are really to help stakeholders. So that might mean the DOT or other industry partners, or even maybe someone like Washington County, but other industry leaders, to ask the right questions when we're developing policy, when we're looking at different programs to establish or to invest in, and where we're actually making investments, whether it's from an infrastructure standpoint or other research. So we think that these are really helpful to look at a holistic approach, recognizing that we might not be able to hit on every single one of these perfectly, but it's an opportunity for us to just give an assessment of, are we looking at things appropriately and really balancing the way that we're trying to make improvements. So they pose different questions. They don't necessarily have a solution of how to maybe address all the safety issues, but when we look at the questions under safety, it's who is benefiting from safety, or who is making, I'm sorry, who is safer because of technology? Are we looking at the safety of people in vehicles? Are we looking at the safety of different roadway users like pedestrians or cyclists, and things like that? So we want to make sure that we're making strides in each of these and being very strategic about it, but also trying to balance it with the work of all other industry partners as well. So a little overview about some of the work that we've done in Minnesota with regards to particularly public demonstrations of automated vehicles. So we've done 3 demonstrations of automated vehicles. The first one is the photo on the right next to the Mayo Clinic. That's the Med City Mover. It was in downtown Rochester from 2021 to 2022. In a multimodal downtown urban environment. We had cyclists, we had people that were walking, we had people in wheelchairs and scooters. We had hotel vans or shuttles driving around. We had international and national visitors. As most folks know probably that are from Minnesota, Rochester brings in a lot of different folks, particularly with the Mayo Clinic. So this route was really unique in the sense that it was in this high demand, multimodal, very complex environment. And a lot of these types of shuttles that are considered highly automated were tested in more of a dedicated track or dedicated lane, if you will, where there's a lot less complexities maybe than what we would see in downtown Rochester. A couple things else to mention with the Rochester project, there were 13 signals on the project that we worked on utilizing technology so that the shuttle would be able to know what the signal phase and timing was. Was it green? Was it red? Was it yellow? Was it going to have enough time to clear the intersection if it was going to be turning red and things like that. Learned a lot from this project. That I'll go into a little bit more on some of those things, some of the learnings on the next slide. But the project was free to ride for the entire year. It really allowed us to understand how vehicles operate, whether they were capable or not capable of different functions, and where some of the opportunities were for us to maybe look at advancements within our own state. Another demonstration project we worked on was the Bear Tracks project that was in White Bear Lake, and that went from 2022 until early 2023. Had some different challenges on that project, different technology company that we were working with. And unfortunately, that technology company did go bankrupt and got bought out by another French company that led into a number of different contractual challenges that ended the project early, unfortunately. But we learned a lot about some of the nuanced differences between these types of vehicles and the technology components to them. And again, continued to advance our understanding and future needs that we might need to look at. And then another project that we have ongoing is not considered a low-speed automated vehicle like the other 2, as it functions at normal roadway speeds. I should note those other 2 vehicles operated anywhere, I'd say, between on average 5 miles per hour and 10 miles per hour. It would note that you could go up to about 15 miles per hour, but I don't think we ever saw it truly achieve that speed on our road due to a number of different varying complexity conditions, like I mentioned before. And that in a manual mode, so if the human operator that was on board did need to take over controls, the vehicle would only be able to operate at 3 miles per hour. So very different when you're looking at a 25 mile per hour roadway movement, and then you bring in a vehicle such as this and operating anywhere between that 3 to 10 miles per hour, definitely had a pretty big impact. So like I was mentioning, that last project I wanted to highlight is Go Marty. It's in Grand Rapids, Minnesota, so a little bit further north and in a little bit more of a rural community, still in a downtown environment. But these are Toyota Siennas, so not that same novel design that you see in those other 2, and fully ADA accessible for 3 out of the 5 shuttles that we originally piloted on that project. So that project doesn't focus the same type of technology where it actually is able to go to a number of different stops and find different routes that it's able to go, as long as they're all still mapped roads that it can follow. So a little bit different in the functionality, and I will note that Nicole's research does not have anything to do with that type of deployment, but just still helpful, I think, to give the context of the different type of AV technology deployments that are out there and the ways that people are exploring to see how they can benefit different communities. So a few of the goals that we had for each of these 3 projects that I mentioned were to really look at how could we advance technology. And in particular, one thing we often highlight is in Minnesota, as you all know, we have cold winter weather. which has its own challenges with just human drivers. So how could we make sure that technology was going to be effective and safer and be able to be operable in those challenging seasonal environments? A lot of technology is currently tested in warm weather environments, so we think there's a lot of opportunity to make sure that we focus on that so that we aren't left behind. I don't want it to be 20 years from now and that there's AV technology fully deployed in southern states, but yet in Minnesota, we don't have that capability 6 months out of the year. So kind of problematic in that regard. We also wanted to engage with different communities, see what they thought about the technology, help them understand where the technology is, what it is capable of, what it is not, and then just ask different questions of how we might be able to make changes to the transportation in the future. Wanted to also about exploring different transportation options. Like I mentioned, not everybody's transportation needs are able to be met with our current systems, and we think there's some opportunities to look at that. And then look at how we might be able to enhance the workforce and provide economic opportunity as well. So a few things particularly that we were able to look at with the technology and that we learned from is that the technology of the vehicles themselves has a little bit of a ways to go, I think would be a fair way to say it. We had some success of the vehicles being able to operate in automated mode with no challenges on a number of occasions, but we also had challenges on a frequent basis, whether it was normal or a sunny day in fall, but happened to have a whole lot of blowing leaves, that the vehicles actually would detect leaves as potential hazards. So the sensitivity of the different sensors and the algorithms that the different technology companies used made it sometimes challenging for it to function in its full autonomous mode. So we had a lot of opportunity to discuss the fact that we needed to have more transparency about the current operating design domains of the vehicles, where their limitations were, whether it was of temperature thresholds for different sensors or cameras, or if it was potential challenges of working with computing and advancing the algorithms that they were writing and trying to progress. We also learned that there were some significant challenges with the maintenance of special vehicles. If a vehicle needs to go out of service, it often might need to go out of service for a long time because there's only maybe 1 or 2 people around the country that have the ability to work on these. Novel vehicles are often manufactured out of the country and have some additional challenges if you're looking at replacing parts, whether that be batteries or other specific computing system portions. And that they also had some challenges with recalibration needs. I mentioned that these vehicles, some of them do connect to the signals to be able to know what the signal phase and timing is. And we had some challenges with maintaining significant reliability of the ability to have that information shared. So there were times where the onboard operator had to override a shuttle because it was unable to capture what the signal phase and timing was. So just because we can get technology to work one time doesn't mean it has 100% success. And so continuing to work to understand how our systems are able to do those things, but also maybe where they're lacking and we need to make improvements so that we have a little bit more reliability. I mentioned that these vehicles use GPS and signal strength in the beginning, sometimes for the automated technology, and in a downtown urban environment, GPS can get a little bit disrupted based on the size of buildings and things like that. It can also disrupt where maybe a vehicle thinks it is based on the information that it's gaining from other sources. So downtown urban environments can be challenging depending on what type of technology industry is relying to make their technology successful. We also learned construction impacts can be very challenging and cause complications to a project because particularly the Med City Mover and the Bear Tracks projects both are considered a highly automated vehicle, but do operate on a fixed route. That means that they are programmed to not deviate more than a centimeter or 2 from the original route that they are mapped at. And so when you have construction and now a lane closed, need a vehicle to operate in another lane, it then makes it where we have to remap that portion of the project for it to be able to function in the autonomous mode. Got some really good opportunities to understand where the vehicles may be a better use and where maybe they might have their challenges. I'll lastly note with some of the technology things that we learned, rain, snow, fog, sun glare, shadows, steam coming out of manholes, all caused some challenges at different times. So we were able to help work with the technology company to advance their algorithms to address those challenges. We also saw that with snow and ice maintenance, that became very challenging. Snowbanks that we have where snows may be built up onto the curb, cause vertical friction where the vehicles, if depending on, I'll say, where their safety bubble is established, can make it slow down, recognizing that there's a potential risk to hit something. And then also removal of snow, making sure that the locations, whether this is for traditional transit operations, traditional pedestrian access routes, making sure that snow is removed and making it fully accessible for folks provides additional challenges. So with the engaging communities, we learned a lot that a lot of folks didn't know what AV technology was, that they had maybe some concerns, but the more that they were exposed to the technology, had the ability to drive on a road or walk on a road with it, or experience the vehicle themselves, the more that they felt comfortable with it, but maybe still have some questions to learn as they go. So we felt as though there was some great opportunity with the exposure of technology that helps people understand and also helps them be able to be a little bit more engaged in the conversation about how we can utilize this technology to better their transportation needs. So that led us to understanding where there's the challenges within communities, and how we can find the right types of solutions for the challenges and the problems that people were able to share. And then lastly, I'll just note with workforce and economic opportunity, we have a lot of conversations with folks, whether they were the operators on the shuttle projects, or the different companies that we talk to that are looking at different partnerships with AV companies. The role of all of our jobs may be changing in the future. And so recognizing that our workforce might have new changes, might have new opportunities for enhancements are things that we're trying to have conversations with, not a traditional DOT role, but we get to communicate and cooperate with our partners at DEED and other agencies to try to understand how can we be proactive and make sure that we're setting ourselves up as a state for success in this industry and looking for that more opportunity for folks to advance things in our state as well. So one thing I'll just note and kind of leads us to why Nicole and I are talking together is one of the things that we learned with particularly our MedCity Mover project and Bear Tracks is that all of our companies that we've worked with so far will say that they're safe. They don't crash into anything and that they have a great safety record. And it led us to ask the question is what is safety and who defines that? And on both those projects, particularly the MedCity Mover with the amount of vehicles and people that were walking and biking around it, we saw a lot more obscurities in the way that people would come close to the vehicle, cut it off, or maybe provide obscene gestures to the operators because they didn't like that it was slowing them down at the lane of traffic that they wanted to use. So we wanted to connect with Nicole and better understand what was happening and why were people actually driving, I'll say, maybe less safe is what we hypothesized. And so we were able to work with her to do some research, and I'll let her share their methodology and what they found about that. But before she does that, one other thing I just want to highlight is that one of the things we're working on in Minnesota is talking about policy with AVs. So there's a lot of discussion about what is there going to be federal framework about what is allowed, what is not allowed for automated vehicles. And right now, there's no federal framework, no federal guidance, no federal laws that say if there has to be a human operator or there can be a computer operator behind the wheel, I should say, who is responsible in those types of things. In Minnesota, you'll see Minnesota statute 169.011. You have a couple subdivisions here that define two things. Both we have defining a driver, which as you can see says every person who drives or is in actual physical control of a motor vehicle. Then you go a little bit further since we take person out of that first definition of driver, and that's every natural person, firm, co-partnership, association, or corporation. I'm not an attorney, but I would argue that attorneys would have a nice discussion and field day fighting about who is right, who is wrong, if there is not an operator behind the wheel in Minnesota. But we are only one of 17 states that does not have explicitly a law that states what is allowed. So with that, we're looking at the different states around the country. Some of them have less restrictive approaches like Texas and Utah. Texas has a significant amount of AV industry interest, a little bit less government insight, but looking at putting a little bit more teeth in allowing a little bit more government oversight so they can pull off bad actors. They provide opportunities with less restrictions to maybe allow companies to take more risks and allow for innovation to maybe happen a little bit more rapidly. There's other states we're looking at that have more of a restrictive approach. California being one of them that I think is the most interesting to often highlight because they have the most amount of technology companies that are testing. Some people believe it'll stifle innovation when you have the more restrictive approach, and it could lead to more legal battles, but you might be able to establish more safety requirements and might slow down some of the innovation that's happening. So both of the types of approaches have their pros and cons, and we're looking at different things within Minnesota that we think are important that will help us look at what are the things that Minnesota wants to achieve when it comes to future automation and the potential of AVs on our roads. So we're working through a policy analysis project. We're not actually drafting policy, but we're looking at trying to prepare recommendations and be prepared should for policy be proposed perhaps in the next year. But looking at what is the AV industry looking for, does Minnesota want to see the risk fall? How do we look at self-certification since there's no formal certification or process from the federal government to date? What's the pace of innovation and growth, and what are the needs here in Minnesota? What are potential legal challenges that we can be prepared for and try to avoid? And then last one, I think that's really important is where does safety lie and who's responsible for that at the end of the day? So before I hand it over to Nicole and let her present on her research, I just had a couple questions that I wanted to pose to the audience to think about. Things that I often think about in the work that we're doing is what is government's role in advancement of automated vehicles? I think often people will think the work that my team is doing is to try to make AVs come here faster or for us to convince the public that automated vehicles are the best thing. And I'm personally not a advocate of that. I think our role is to make sure that as technology and changes occur, that we're making sure that the people are benefiting from them the most and that we're actually meeting the needs of the people. But I think it's a question of what is our role from the management of automated vehicles and the way that it changes our system. And then one other one is better for some, but not better for all still better? I think this might be a question that we can ask as we start to see if people in vehicles might be more safe from technology, but people outside of vehicles are less safe. Leads me to the question of what if disparities of safety or other things increase when we still have advancements overall. So not necessarily a popular question to pose to folks, and it gets a little bit of stares of there's not a right way to answer it either, but I think it's a fun one to ponder. And then lastly, I mentioned at the beginning, safety, accessibility, and equity are three things that I think can really be achieved if we focus on those as the outcomes of technology and the advancements. And so I just wonder, can we truly achieve all of these? Or is that maybe a little bit of wishful thinking that might not actually come to fruition? So with that, thank you all. Feel free to contact me if you have any questions, particularly about our CAV program. I know I didn't go into a number of the different projects that we work on besides the public demonstration projects, but happy to chat with folks offline if they have any questions as well. So with that, I think, Nicole, I will hand it over to you.
Thank you, Tara. All right. All right, well, thank you everyone for joining. Excited to see some familiar names in the attendees and some that I have not met before. It seems like we may have some folks from out of state, so welcome. For those of you who don't know me, I'm Nicole Morris. I am a human factors psychologist and I sort of play engineer in the Department of Mechanical Engineering. I'll talk a little bit more about what human factors is. But first, I want to just introduce my research laboratory. So we are the Human Factors Safety Lab, and our real mission is around reducing the occurrence of roadway and occupational injuries and fatalities. And we do that by taking our understanding of human behavior, human perception, decision-making, cognition, and applying that to design. And in particular, we really emphasize user-centered design or human-centered design. We work really diversely across a lot of different domains. The transportation system is such a great place to do human factors work because there are so many interactions between people and systems, and trying to optimize those systems to accommodate humans and help us achieve our safety goals. So for those of you who may not be familiar with human factors, just really high level, I think it's most simply described as the marriage between psychology and engineering. And so we're really at that intersection point between people and systems. And so how are people interacting with systems? We can design really amazing, beautiful technological systems, but if we haven't really accounted for how people will use them, what kind of error might they have? we may be mitigating one type of error, but introducing a new type of error with a system. And so we're really looking at improving safety, enhancing the user experience, making things really fluid and smooth, again, by taking what we know about the capabilities and limitations of people. So with the MedCity Mover, this was just such a great project, and really, I think one of my lab's most successful projects to date. I'm really proud to talk about the good work that we did. So as Tara mentioned, they had this deployment of the MedCity Mover, this low-speed autonomous vehicle. I often like to bury the lead, just how slow we're talking when we say low speed, but Tara already gave away the good stuff, that this thing was going very, very slowly. So we're talking, around 10 miles an hour, so very slow. And this was in downtown Rochester. We had some conversations kind of leading up to this deployment about, what might happen about how drivers of manual vehicles, how will they be interacting with these autonomous vehicles, particularly those that they know to be autonomous? Will their overtaking behaviors change? Will their following distances change, depending on their trust and risky engagement around? So thankfully, we had those conversations already going, and my team is often engaged in a lot of field work around pedestrian safety. And so crossing intersections, looking at how drivers are interacting with one another as they're yielding to a pedestrian and a crosswalk. And so all the stars really aligned for us when this deployment happened, and they were identifying that there was indeed some risky overtaking occurring near the MedCity Mover. And like Tara mentioned, some obscene gestures or, really unkind types of interactions between drivers of the manual vehicles and the shuttle, or the folks on board the shuttle. So they reached out to us. Can we really, first of all, really determine what is the extent of these risky behaviors? So it's very easy to kind of inflate incidences if you're not really accounting for base rates. So, you see somebody overtake the MedCity Mover in a particular way, that might seem really risky or unsafe or unique, but it's really important to determine how often does that happen around a regular vehicle, and this very specific type of infrastructure that may invite that type of overtaking to begin with. So there's really some controlled experiments that need to be done to determine those risks. And then really we wanted to identify what is going on if there is indeed increased risk around the MedCity Mover, what's contributing to those risks? And finally, we really wanted to come up with some solutions. How can we mitigate those risks? So this is a picture of one of the stops of the MedCity Mover. It had two main stops, and I'll show a map here shortly. But those of you who are not familiar with this area, it's a very heavy pedestrian corridor. It's near the Mayo Clinic. And so you have a lot of traffic. It's not particularly really dense. It's a smaller city in terms of traffic, but there is quite a bit of traffic and a tremendous amount of pedestrian traffic. So you have doctors and nurses and patients and family members and people that work in downtown, just a lot of people crossing these crosswalks. And so what was really unique and forward-thinking to do this deployment was to look at how would a system like this work in a really pedestrian heavy corridor. And so I'm going to talk about our research process. So typically when we're doing a human factors study, that kind of adage is early and often. So when you're doing human factors work, you really want to be involved at the ground floor of the design, at beginning of ideation and prototyping, and you work your way from kind of lab to the field. And that's really the optimal path typically to avoid some issues. But often, as in with this case, we get brought in very late. So rather than beginning in the simulation lab or in the lab and working our way to the field, we had to begin in the field. This thing was already deployed, it was already built. And so it really changed the process that we needed to take. And we really kind of went in the reverse order of what we would typically do. And so starting in the field, and we kind of worked our way through all of these different phases. So I'm going to talk about nearly all of these, with the exception, I'm not going to dive too much into the interviews with the operators of the shuttle, but that was highly illuminating and helped our process. But really going to talk about what we learned in the field, and then how did we start to, taking what we had observed, really measure the risk, try to come up with ways to manipulate what people are doing and determine, are we able to actually mitigate those risky driving behaviors? So we began in our field observational test. You can see this map rendering here. So the MnDOT mover went in this just square loop. So it was all right turns, and it was turning at 3 signalized intersections and 1 unsignalized intersection. It was a stop controlled intersection. And we had the opportunity to do testing all along here. So this was our field observational test. So we had 3 main data collection methods in the field. So first we were doing stage crossings at the unsignalized sites. And then we were looking at turning vehicle observations at the signalized sites. And then we also did onboard observations along the route. So part of the reason why we do stage crossings at unsignalized intersections, so unsignalized intersections just by nature don't have a lot of pedestrian traffic. So you really have to create those conflict points and stage a pedestrian crossing. So you can see where I have these little pedestrian icons on the map. These are where we did some of our stage crossings. We wanted to do some measurements on the route and also off the route. So it was important to try to capture, you know, is the MnDOT mover somehow, because it's driving along this route, changing driver behavior on the route, and also accounting for just driver culture in Rochester and downtown Rochester in general. So you can see we have 1 unsignalized crossing that's off the route and a couple of signalized crossings that are also off the route inside that square. So that allowed us to get a lot of observations. We did do a bit of stage crossing as well at the signalized sites, but thankfully there was plenty of pedestrian traffic that we could just observe those observations or those interactions, excuse me. But then we also wanted to look at onboard, see continuously what's happening with the shuttle as it goes through this route compared to a research vehicle. So we did the study for 13 weeks. So we began kind of right at the start of summer, as soon as the weather really cleared and we had all the snow was gone, we began. And so we went down there every week and did this for 13 weeks. We did 2 days of data collection each week during the hours of observation of the MnDOT mover. And again, we were really focused on that overtaking and yielding rates around the MnDOT mover. One of the things that we heard really early on from MnDOT, what they were hearing from the operators, was that as the MnDOT mover was yielding to a pedestrian in a right turn at a signalized intersection, people were going around on the left. So this is what we would call a multiple threat pass, where one vehicle yields and another goes on through. And my team has done research studies, and the Twin Cities, we've crossed the street, you know, thousands and thousands of times, 20,000 times, I would estimate. And we had never observed a multiple threat pass at a signalized intersection in a right-hand turn. So we knew this was really something very unique that we were dealing with, that we wanted to be measuring. So looking at those overtaking while yielding was occurring simultaneously. So that was really important, because that's a very risky proposition for a pedestrian. So very high level, one of the things that was very apparent was that there was increased queuing behind the MnDOT mover. And this is important because if you're going to have a vehicle that's going to overtake the MnDOT mover in a multiple threat pass at a signalized intersection in a turn, you really have to have that increased exposure of risk. You have to have vehicles stacking up behind you, at least one, if not more, vehicles stacking up behind you in a queue, a line, to increase the risk that you would have that following risky behavior of the overtaking. And so it was really clear from day one when we were down there that that was something that we had to be measuring, not just the overtaking behavior, but the creation of a queue. And again, if we throw back to what Tara was saying, this is a 25-mile-an-hour road. it hadn't been too long since it was changed from 30 miles an hour. And so you can imagine the fleet is traveling likely faster than 25 miles an hour, but the MnDOT mover is not going that fast. It's going maybe around 10. So you can imagine it's really creating a lot of queue behind it because it's going so slowly. The other thing to note is that at the signalized intersections, it cannot go right on red. And the signalized intersections that it was turning at permitted right on red. There was not a no right on red sign at these intersections. So it was the norm to go right on red at these intersections, but it simply couldn't go fast enough to accept gaps. It could only take the right when it had the green ball. Of course, when it gets the green, that activates that secondary crosswalk. So you're going to get natural conflict. When it's time to go, you have to then stop because there's lots of pedestrians. So again, we captured that that queuing, and we found the MnDOT mover was 4 times more likely to experience a queue of vehicles, particularly when yielding to a pedestrian in the crosswalk relative to other vehicles. So that in and of itself, we can see that the low-speed autonomous vehicle is creating traffic disruption because it is increasing that queuing, and so it will increase the risk of other behaviors to follow. So that gets to our multiple threat passing around the MnDOT mover. So as those queuing began, then we would start to see that the risk of overtaking grew pretty dramatically, particularly if it was the MnDOT mover. So we found that the MnDOT mover was 48.9 times more likely to be overtaken by another vehicle while turning compared to other passenger cars. So even if there wasn't a pedestrian and it was trying to turn, you would have overtaking of vehicles at a really high rate relative to seeing that very rarely happened with other vehicles. And I will note it did happen, just not very often. Where a regular vehicle would be overtaken. And then we saw that the MnDOT mover was also 36.4 times more likely to be overtaken by other vehicles while yielding to a pedestrian at an unsignalized crosswalk. So we saw a lot of this overtaking behavior at the signalized crosswalk. Sometimes the pedestrian was in the crosswalk, sometimes not. Often the pedestrian had already cleared the crosswalk, but it took some time for that MnDOT mover to get up and go. So we saw just a tremendous amount of increased risk, again, that we would attribute to that queuing. It's not completely moderating that risk, but it is a partial mediator of risk with that queuing. So next we did our ride-alongs. And so again, we wanted to see more continuous interactions. We really only had so much data that we could deal with when we were at the corners observing that overtaking. And as Tara mentioned, this was problematic. There was often supposed to be 2 MnDOT movers in operation, so that would double our data collection, but very frequently one would be down. And so we would only have one, and so we kind of have to wait around every time it would come through. It'd take quite some time for it to make its loop. So right along the MnDOT mover gave us an opportunity to look at other types of overtaking behaviors rather than just at those signals at the turn. So we did this where we would ride along the MnDOT mover. So each day we had data collection, we would do an onboard data collection session. We would ride along for 2 loops, observing the overtaking behavior, and then we would drive a research vehicle along the route in 2 loops. The research vehicle would go exactly the speed limit, so it was obviously going faster, but we did not go right on red. So that was one behavior that we did try to match across the 2. And so we were looking for 3 main types of behavior. For overtaking, we would say the first one, you see this yellow. So that's overtaking, kind of cutting off from the other lane. So often there was 4 lanes of traffic, 2 in each way. So there may be a vehicle that would come up from the other lane, but then cut very closely in front of the MnDOT mover. So that would be a cutoff from the other lane. Then we also had change lanes from behind. So that's blue. So coming up behind the MnDOT mover and changing lanes behind. And then the kind of worse one, the double whammy. So they would come up behind the MnDOT mover, change lanes, but then cut off in front of the vehicle. So that would be a cutoff from behind. So we were observing how often did that happen with the MnDOT mover versus the research vehicle. And we're also looking for yielding and multiple threat passing along those routes as well. If we had the chance to see the MnDOT mover yielding to a pedestrian and the research vehicle. So We certainly saw an increase in risky overtaking of the MedCity Mover. So the cutoff from behind, we solely saw that on the MedCity Mover. We didn't observe that in any of the loops with the research vehicle. And then cut off from the far lane and change lanes from behind. Again, we saw a big risk. So this was like 13.6 times more likely to be cut off via lane change. And so you see a lot of risk. Now you may be thinking these are like ticky-tack things and people change lanes all of the time. These weren't just lane changes. These were really cutting in very closely to the MedCity Mover. And the reason why this is really problematic for the MedCity Mover is if you got too close into those sort of bubbles that Tara was talking about, it would engage a hard braking maneuver. This is a big reason why it really can't go much faster than 10 miles an hour. These hard brakes were pretty intense for the riders on board. And so if someone cut off, got into one of those bubbles and the MedCity Mover engaged in a hard brake, it would be a very rough ride for the passengers on board. And there was one incident of someone cutting off the shuttle, braked and had a minor collision with the MedCity Mover. So we certainly don't want these types of behaviors occurring. It just increasing risk of rear end crashes, sideswipe crashes, and ankle crashes. We also saw along those the increased risk of multiple threats. So this is kind of a diagram of one of the crosswalks that was along the route, an unsignalized crosswalk. We saw that there were multiple threat passes when the MedCity Mover was yielding to a pedestrian at this crosswalk. We never once saw a multiple threat pass when the research vehicle was yielding to a pedestrian in this way. I just want to note that this study is published in IEEE, so I think I can probably put a link in the chat if anyone would like to get more details about this. So I've already talked a little bit about the speed in which the MedCity Mover traveled, but one of the things that was really interesting to us was looking at how was the MedCity Mover communicating with other drivers. And so this is sort of an exaggerated version of what something might look like in a yielding situation. But what we found was that when the MedCity Mover engaged in a yield to a pedestrian, the operator on board would take over manual control of the shuttle. Just a more complex interaction that is smoothed out by the operator taking over manual control. And when that happens, the vehicle's hazards come on. So now I want you to sort of imagine you've been traveling behind this MedCity Mover that's going about 10 or 11 miles an hour, and you come up to this crosswalk and it's red, there's plenty of gaps, it doesn't take it, finally it turns green, it begins to go, it stops because it's yielding to a pedestrian obscured by the shuttle in that secondary crosswalk, and its hazards come on. And what might you then conclude as a driver who's quite frustrated to be following this thing? You may conclude it's stopped, it's broken down, it's boarding, it's loading or unloading passengers. And so what might seem really aggressive might be just a logical conclusion that a following vehicle has, which is I should go around this thing. But we really wanted to start to disentangle this in more controlled experiments. Can we see what are the motivating factors for people to overtake or choose to overtake or change lanes behind the MedCity Mover? Is it the appearance that they know it's an automated shuttle and they can kind of push it around? Is it because it's going very slowly? Are they confused by what it's signaling to them? So those are some of the questions that we had. So first we did what I would consider a low fidelity simulation. So this is just sort of a screenshot of what these look like. So we took our high fidelity simulation software. Peter Easterlin, who's a genius in building simulations, rebuilt the MedCity Mover to spec in our simulated world. And we created these short videos for participants at the D2D building at the Minnesota State Fair to participate in. And essentially what we asked them to do was watch this shuttle. And so kind of like you're driving, so either a little passenger shuttle, like might pick you up at the airport, sort of a van versus the MedCity mover. And they kind of just had to painfully watch as they followed behind this vehicle like they would be a driver. Half of the case, they were going very slowly, about 10 miles an hour. Half of the case, they were going the speed limit, 25 miles an hour. The length was the same. So they watched it the same amount of time, but they just covered more ground when it was 25 miles an hour versus 10 miles an hour. And then it would come up to this unsignalized crosswalk, and then they would just be presented with a forced choice. Would you wait behind this vehicle, or would you overtake? And so this helped us to determine, is it the appearance or the speed of the shuttle, just the overall appearance of it looking like this kind of futuristic automated shuttle or regular vehicle, or is it the speed? And we found, you know, some differences, but not significant with the appearance. Certainly we did find that it was the vehicle speed was predictive of people's decision to pass the vehicle. So we knew that speed was a major factor here. The challenge is the shuttle really can't go much faster. So we know that that's a risk factor and something that we should all really be mindful of. Then when we think about, you know, disruptive technologies, this is truly disruptive and not in a way that we likely want. Of course, going slowly is safe, but if you're going so much slower than the rest of the fleet, you're going to really invite a lot of problems. So how can we try to design our way out of some of these misinterpretations about what the shuttle is doing? So the next phase we did was to look at what we call a crowdsourced driver interpretation study. So this is a really great opportunity for us to get a big number of people through what we call crowdsourced data. So we use an online site called Prolific, and we loaded in a lot of these short little videos or GIFs to have people view and then give us their interpretation. So we wanted to see, can we mitigate people's decision to overtake depending on how we presented the information? So we were looking at a number of different types of signals here. So we showed them kind of the shuttle at different places along the route. And we wanted people to say, what do you think is happening? What is the shuttle doing? And would you overtake? And so it was pretty simple how we presented this. We looked at what we call the hazard condition, where it activated the hazards, just a regular turn signal that you would see as a vehicle is intending to turn but hasn't progressed on. And then we looked at a text icon version. This is only showing one iteration where it says ped-Xing. We also had another that it was pedestrian crossing, so fully spelled out. So looking at people's decision to overtake, when we presented them with the short video of the double flashing hazard, you can see we had much more frequency of people saying they would overtake than these other conditions where we had just the turn signal on, or the pedestrian Xing or pedestrian crossing that was really decreased. We also found that if they said they thought the vehicle was yielding to a pedestrian, then their likelihood to say they would overtake went down. And we also were looking at their response time. How long did it take them before they made their selection? Really trying to get a little bit at what is the cognitive process? Is it more confusing and you really have to think about what you think it's doing versus it being just very intuitive? What is it doing? And again, we found the hazard condition, the response time was quite slow. So in the last iteration, we took all of our work and pulled this into our high fidelity simulator. So this is not an image of the MedCity Mover simulation, but one of my favorite pictures of the sim, so I used it. But this shows the Human Factor Safety Lab simulator. So it's a full vehicle chassis that moves. We have an arc screen that wraps around, and Peter builds these beautiful custom worlds for us. And so we created a number of different scenarios where we were forcing interactions between the participants in the study and the MedCity Mover. We really capitalized on what we often saw in Rochester. There was a lot of road construction that summer. And so frequently the roadway would be reduced down to one lane because you had construction closing off one of the lanes. And so that helped us kind of create a more forced interaction where they really had to be following the shuttle, but it was highly valid because that really is what was happening in Rochester. So you can see where we have those the yellow marked off sections, that would be where barrels are. And then we could sort of force some of these interactions where they'd be forced to follow the shuttle, but then it would open up and give them the opportunity to overtake should they choose, and then opportunities to yield to pedestrians at unsignalized crosswalks or at signalized crosswalks in the right-hand turn. We did choose to take the PED-Xing condition. I'd say the pedestrian crossing condition did do slightly better in our crowdsourced study, but we don't have quite the same resolution in the simulators we did in the real world. And we didn't find any significant differences between those. So we opted for the PED-Xing condition. And then we also had a double flashing hazard condition and a simple turn signal condition to see, can we, one, validate and see that we can observe the same types of overtaking behaviors in the simulation that we saw down in Rochester, but also can we mitigate that overtaking behavior when we present the PED-Xing or pedestrian crossing text icon condition to people to have some insight under the hood, so to speak, of what the automation is doing. So we found that participants were less likely, significantly less likely, to overtake the MedCity mover in the text icon signaling condition relative to the hazard flashing condition. And we saw that the text icon signaling condition more clearly represented a turning vehicle. So people could really interpret, tell us after the fact, they knew what it was doing, and so the behavior that we saw in the simulation wasn't quite as extreme as what it was in the real world. When people come into our simulation lab, they usually want to show they're good drivers and do a good job, and they're less likely to engage in some of that risky behavior that we see in the real world, where people are very motivated to speed and get home. And when they come into our lab, they certainly just want to do a good job. So the fact that we still observed some of these confusions and overtaking behavior and were able to mitigate it in the driving simulation, to me shows that we would have tremendous potential to mitigate some of these risks in the real world by implementing something like this, where the automation really works to communicate with drivers behind it, to tell them, what is it doing? Why am I stopped? I'm not stopped because I'm loading passengers, or I'm not stopping because I'm broken down. I'm stopping because I'm yielding to a pedestrian. And so I think there's a tremendous value in this finding. So to nearly wrap up, I always like to do a bit of an academic quote here. And this is one of my favorites. I think it's really important as we think about how automation works in terms of achieving our safety goals. Because often when we think about traffic safety, we hearken to these stats of, 93% of our fatalities are from human error, human behavior. And so we often think that the solution is just to remove humans from the equation altogether, that if we can just automate our way out of this problem, we will achieve our safety goals. But the thing to always remember is this quote. So this is from the late great Per Sermon and his colleagues, that automation does not merely supplant human activity, but changes the nature of the work that humans do, often in ways that are unintended and unanticipated by the designers of automation. So if you think back to, my beginning of human factors really works best if it's early and often, but so frequently, these companies are racing to be at the front of the line to release this technology and get it out into the field. But if we're not really thoughtful about employing human-centered design, being careful and diligent to see how will people interact with this technology, how will this change the way that humans interact. And there's another quote that I don't have here, but that really thoughtfully says how adding automation is like adding a team player who does not speak the same language nor share the same cultural assumptions as those around it. And the MedCity mover certainly did that. It was, didn't speak the language of the drivers in downtown Rochester, didn't share the same cultural assumptions, behaved very differently than everyone around it. And that is going to create disruption, and it's going to create these unintended, unanticipated consequences for these interactions that, yes, we may be mitigating risk in one way, but we may be introducing risk in another if we aren't thoughtful about it. So in conclusions, our field study did confirm that the MedCity Mover increased risk of being overtaken relative to a regular human-driven vehicle. And this was during that free-flowing traffic, all continuously while it's driving, but particularly and quite scary while yielding to a pedestrian. And so along what Tara was saying, you know, when we're talking about safety, it's for whom? Who is safer? And so we may be making the people on board automated shuttles like this safer because, you know, the driver isn't prone to distraction and is going very slowly and is following all of the rules of the road. But we may be putting those around the vehicles at greater risk because it isn't meeting all the expectations of the fleet. And so we did find that the MedCity Mover was highly compliant in yielding to pedestrians, and that is really great. But it is really important to see how that may change the way that other people are interacting and putting pedestrians and cyclists at risk. Certainly the speed and the hazard signaling we feel were the biggest contributors to why people were overtaking. The speed, of course, contributed to that queuing. But then if you're in the queue and you don't correctly interpret what that signal was telling you, it was a highly logical conclusion, in my opinion, for people to overtake the MedCity Mover when they think it's just simply broken down or stalled or some other reason, but certainly not yielding to a pedestrian. That wouldn't be a logical conclusion. We often think of, you know, stimulus response confusion. And so hazards are not used typically for yielding to a pedestrian. They're used for other ways, typically meaning that the vehicle is stopped, will remain stopped, or is broken down. So we have to be very careful as we're kind of capitalizing on other signals on these vehicles that have been historically used for other meanings and trying to co-opt them to communicate other things. So I think that there's a lot of potential with this EHMI, this external human-machine interface that we developed. There's been a lot of work leading up to this where we've been looking more at things at the front of the vehicle. How is the automated shuttle communicating with pedestrians and cute little eyes that are looking this way and that. But I think we may have missed the importance of these shuttles needing to communicate with other drivers. And I know I wasn't going to spend too much time on this, but I think it's really important to note that the operators were doing a tremendous amount of work to smooth out interactions between the shuttle and other drivers. And so as we're thinking about this idea that, oh, what a great opportunity that we can remove drivers and handle some of these workforce issues that we have by fully taking an operator out of the vehicle, we certainly wouldn't want to do that with shuttles like the MedCity Mover. For one, they have to take over control of the shuttle quite frequently. So very, very rare for it to make it through an entire loop without having to do at least some momentary manual control of the shuttle. So that may be for things like Tara was mentioning, obstructions in the roadway, road construction, other just unforeseen things. But often the operators would start to anticipate, when I get to this section in the route, there's going to be trouble. It's going to make people around me really mad. And so it's far better if I go ahead and take over manual control. That's a faster process. Then the automation giving and taking control itself. So they would take over control, drive through this kind of problematic segment, and then give back control to the shuttle. So certainly couldn't navigate the route on its own, but in the interim, while the shuttle is doing all of these things, they're doing a lot of gesturing, and I don't mean obscene gesturing, but just really sort of trying to gesture and smooth out and tell people to go on around or wave or try to do things to de-escalate the situation. And I think that that's really important for us to continue to further study. What are these onboard operators doing? What types of human-to-human interaction are they taking to supplant what the automation is missing? And so if the automation is not able to give that under the hood perspective, we talk about out of the loop automation. And so typically that's the operator that gets out of the loop of what the automation is doing, and it's very hard to take control. But the drivers around the shuttles are also very out of the loop. And so the human operators were really providing that level of communication. And so modeling and determining what those operators are doing, how are they communicating, and then building that into the EHMI so that the shuttle itself is communicating with human-driven drivers will be a really important thing to do in the future. Right, so I'm going to say thank you, and hopefully we have lots of time for a lively chat.
All right, thank you, Nicole. So I just want to remind the audience at this point to use the raise hand feature if you wish to ask your questions verbally, or you can type your comments and questions in the Q&A feature, which is down at the bottom. I see we've got one, possibly two questions in there already. And I can give, well, let's see, why don't I take one of those first, and then we'll see what other ones roll in. So first question was, what was the speed limit along the Med City Movers route? And did it seem like the increased aggressive / risky driving behavior was due to the speed of the Med City Mover or the autonomous nature of the vehicle?
Mm-hmm. Yeah, so it was 25 miles an hour. And not long before that, we had a change in the state statute to allow our municipalities to reduce the speed limit of their roadways. And so it hadn't been very long that it had switched from 30 miles an hour to 25 miles an hour. And I don't know that there was much change in the actual speed. It was just the speed limit had changed. So it had probably vehicles were traveling close to 30 miles an hour, if not more. I will say that in some of the sections where we had road construction, people were traveling fairly slowly because there was road construction and they were really mindful of that lane closure. So in not all sections of the roadway was the fleet traveling as fast. And when there was absence of road construction, I would say Broadway was probably the segment of the route where the speeds were highest. And you would see some of that overtaking behavior. You may have an issue where, you know, the shuttle is traveling in the right lane, a vehicle comes up in the left lane to race ahead and cut off and take a right turn in front. So, you know, doesn't want to wait until that vehicle gets through the signal, doesn't want to risk that it doesn't make it through the signal. So they would go from race pass in the left lane and cut across and go over. So that sort of just gives you a flavor of the types of speed interactions that we saw. I do think that the speed was a big contributor to people's impatience with the shuttle. So I think that was a big part of it. People were very impatient because it was going so slowly. And if you were in Rochester a lot, you worked down there, you lived there, had a lot of interactions with the Med City Mover, you probably would have observed it just randomly sitting on the side of the road with its hazards on. So, you know, the interpretation that when I see its hazards go on means it's just stopped would also be a logical conclusion, because frequently it was just stopped on the side of the road, experiencing some sort of a technical issue. So, you know, I think we modeled our findings. We could find that the queue was a partial mediator of the overtaking. So I would say that, you know, the queue to me is a good indicator that the speed is a big problem, but it didn't fully explain. So if we controlled fully in that mediation analysis, it wasn't a full mediation of the overtaking risk. So I would say other things like the appearance and the signaling, not going right on red, and then using the hazards also contributed to that overtaking behavior.
Nicole, can I add one more?
Yes.
I think even the sensitivity at which it was programmed from an autonomous feature, like if you were even taking a right on green, often was the only vehicle that could get through, because if there was a pedestrian within so much distance, it automatically didn't cross, where often people that are in a high volume, dense environment, rush hour traffic would just kind of squeeze their way through safely. And it didn't. And so I think that frustration of the conservative nature of the programming also made it even a little bit more disruptive.
Yeah, absolutely. Oh, you're on mute, Joe.
Sorry, I didn't think I had put myself on mute. Just to clarify, so this vehicle would, the Med City Mover would not turn right on red, even in the absence of pedestrians. It was programmed just to not take advantage of that ability.
That's right. Yeah. I mean, particularly at Third and Central, I'm saying those streets right. I have to look at my map. Third and Central, it would be pretty rare. Oh, sorry, Third and Center. My apologies, anybody in Rochester that's like, that's not right. Third and Center, it would be really rare that you would have no traffic coming along Center. I mean, if you were at Third waiting to turn right, there would be traffic. I mean, inevitably there would always be traffic, but there would be gaps that a normal human-driven vehicle could absolutely take. It just couldn't take those gaps. But then the moment it got the green, that walk signal would activate of pedestrians crossing Center, and it'd be a lot of pedestrians, and it's a wide street, so it would take a long time. You could imagine some of those pedestrians were in walkers or wheelchairs, and so it was common that it would take 2 cycles for the Med City Mover to be able to get through that intersection, because it couldn't go right on red. It would get the green, it would be obstructed by pedestrians, and that walk signal, by the time the pedestrians actually cleared, time's up and the red comes again. So I'm sure that was immensely frustrating for people to wait 2 full cycles to get through that intersection.
So you may have already answered the follow-up question that I have here. So when the light would go green, I gather that this the Med City Mover would not do what a normal human would do, which is to pull out into the intersection while yielding to that pedestrian when making a right turn. So state driver's manual would specifically say this for left turners. I think it's implied for right turners, is that when you are making a yielding turn, you pull out into the intersection, and that way you always clear at least one vehicle through at the end of the cycle when the signal changes to red. But if the Med City Mover is waiting through multiple cycles, it sounds like it was maybe not doing that, which might have further led the driver behind them to conclude that it was stationary or malfunctioning, because it wasn't doing what we would expect of a human driver.
I think it would move forward, wouldn't it, Nicole? But it would move forward minimally, because it would automatically sense something.
Right.
When the red happens, it was programmed to not go. So the operator at times did override and drive through manually to, Joe, as you mentioned, get through the one vehicle per cycle at a minimum at the end of the cycle, but it had to override it because it otherwise was hearing the signal saying red, can't move.
Yeah, that is right. So it would go forward, not much, but you know, if you were behind it and it turned green, you would see it begin to move. But it just wouldn't go very far. It certainly wasn't getting itself into the intersection, but it would move, stop, hazards come on. And so again, that sort of like pattern is either highly frustrating, even if you know what's going on, but very frustrating, particularly if you don't know what's going on, and easy to misinterpret what the heck this thing is doing and why, you know.
All right. I got a couple more questions in the chat. Let's see, we got one that says, is there a similar Europe comparison that you've looked at or learned from? And I might add on to that another international flavor. So cities that have streetcars, such as Toronto, might possibly pose similar incentives for drivers. If you know that it's not something that you want to get stuck behind, you might take advantage of any opportunity you can to get around. Did you compare this to other locations internationally or other similar behaving vehicles?
We weren't able to find other studies that have done this type of observation. So not to say that it hasn't occurred or hasn't occurred since our study. A lot of the things that we were finding would be case studies from, say, California, where you would have, you know, someone would misinterpret what they thought the shuttle was doing, thought it would stop and it didn't, or so on and so forth. But we didn't really find much work that did this exact type of analysis. So I would love to see anything if someone has something to share. But I do think that certainly because these are European shuttles, you would think that there would be lots of opportunity to study these other places. We aren't familiar with this type of study.
All right. Next question in the chat says, is the goal, I'm thinking this is the goal of the people operating the shuttle rather than the researchers, but is the goal to increase the operating speed to better match driver speed, knowing that this may prevent many of the issues that other drivers are creating?
I'll take a stab at this first. I think the goal would be to match operating speed with the use of the roadway, whether that is vehicles or if it were on a dedicated path or if it were in a multi-mixed environment. Like, it just kind of depends. But with that being said, I think it's fair that everybody that was on this project recognized that the low speed shuttle going at the max speed of 13 to 15, but average 7 to 10, downtown Rochester, not a great place for it. So I always use this as an example of there's a little bit of responsibility on the manufacturers to figure out the appropriate use case, and no longer, I'll say, customers like us to say, well, let's see if it works. Well, why don't we try to do a little more homework on the front end? But with that being said, there are companies that are developing shuttles that are novel vehicles that don't meet FMVSS compliant regulations, get exemptions from the US government to be able to be tested. And Holon is a company I know that's working to operate around 25 to 30 miles per hour. So that type of technology is continuing to be advanced, and it would be really interesting to see how that would function in Rochester, because we know speed's an issue, but no longer maybe that is, but maybe it's still the communication between human operators and an autonomous vehicle, and that might still be something that would need to be explored, like Nicole's team did. So I think there's several issues with regards to this project or this specific vehicle itself. Speed very much, I think, is one, but to the point, yes, finding the appropriate technology capabilities that match similar operations of the traveling path or the roadway is probably more appropriate.
Yeah, agreed. We certainly would not, wouldn't want this shuttle going faster, I would say, just because of its capabilities. And that'll kind of get into, I can see this next question about seatbelts. But yeah, I mean, we certainly don't want speed differentials like this on our roadways. And the risk at 25 miles an hour is fairly low. So, we're not talking about kind of some of these really serious speed differentials that you would see on freeways or highways. But it's still risky to have a vehicle traveling so much slower than other vehicles. So that would ultimately be the goal. But the signal detection problems are going to have to be worked out before it can go faster. And we're just not in a position with this tech. There's certainly other players out there that are able to go faster, but the way that these sensors and processing works certainly cannot go faster. So we heard quite a bit of comments like, oh, we'd go faster, but NHTSA won't let us. And I'm like, I don't want you to go faster. I don't care who lets you or not. You can't go faster with the type of technology that we're dealing with.
All right. Do you want to roll right into the ICUC? You mentioned,
yeah, I can see it.
Right,
so maybe I feel like I can speak to this, but maybe Tara can answer the first question about were riders required to wear a seatbelt, and would this increase rider safety?
Yeah, so prior to us contracting this project, no, they were not required to. At a national level, there was an incident though in 2020, I think it was out in Ohio, where people were not belted, they were seated, and operations came to a halt due to, I don't remember what it was, maybe it was a leaf in the roadway, but everybody kind of fell, and I believe a couple of the passengers got a head bump, minor injury. And then out of precaution, the because they are not FMVSS compliant, they have to go through a certification process and get a waiver to be able to be exempt and continue and be able to operate. They then put a rule in that people had to be seated and belted. So prior to this, we anticipated, I think, being able to carry 10 to 12 passengers with people standing and seated. And then when we operated, it was only seated and 6 because we had 6 belts on it, and then it was during COVID, so we even tried to limit that a little bit more. So yes, now they are required in non-FMVSS compliant vehicles to be seated and belted, except for the operator. They are the only one that does not have to be.
Yeah, so the incident in Ohio, I think that was a state employee. One of them was elderly and was thrown from his seat. His face hit kind of a bar, and so you can find pictures online of his facial injuries. So it's a good reminder of the risks of these hard braking maneuvers that the shuttles are likely to experience. And so even though they're going at 10 miles an hour, a very hard brake at 10 miles an hour is still a tremendous amount of acceleration for people on board to experience. And so, you know, and you can also, I think there was another incident that I found a video online in another state where people were thrown from their seat in a hard braking maneuver. You know, I think the other thing to sort of consider is that these shuttles, unlike other types of public transit, are very low to the ground. So unlike what you would see with a school bus or a large, like a Metro Transit bus, where that force of impact of another vehicle often would go low and kind of under the frame of the vehicle, these things are so low, dragging the ground. And so there's also just a lot of risk of the occupants with the impact of a crash. And not quite the same crumple zones that you would have in a lot of other vehicles that are also low to the ground. So kind of getting a little bit off topic, but I think, you know, just a good reminder of all the sort of things that we're trying as we're trying these kind of futuristic, very lightweight shuttles, but many of the traditional safety features that you would have in public transit are not present. And so we really have to be mindful of where are we deploying them? What is the potential force of impact if they are involved in a collision, and making sure that they're belted. Certainly I was riding another Easy Mile shuttle, which is what this was in Florida. And it had a hard braking maneuver that didn't even seem that too extreme. But my seatbelt was holding me in. Like I would have toppled out of my seat with that hard brake. So certainly really important to make sure that we're buckling in these types of things because of the hard brakes. And I'll also note, I think in that Ohio hard brake, they never could conclude why it braked. So it was just sort of potential noise in the system.
I think the lesson there is wear your safety belt whenever there is one provided.
That's right. 100%.
All right, let's see, we got 3 more questions I see in the chat, and then I have 1 more if we have time for it. So just a weather question: does the long snowy winters in Minnesota hinder the advantage of driving automated cars in Minnesota?
I personally think of it as a huge opportunity that we provide to allow technology to get this right one and done. But unfortunately, a lot of the industry tries to focus on where can they make it to the next quarter from a financial viability perspective. And that often is where can they just make advancements in the easiest place, which happens to be some of the more mild temperate climates, which I guess maybe Arizona and Florida are not temperate in some fashion, but they don't have the cold, right? And so just different extremes. And I think one of the things that we have the biggest opportunity for is if you can get through the cold winter weather, whether it's the snow, the ice, or the horrible temperatures that you might get further north. And also I'll say rural gravel roads. When you can tackle all that, you've tackled it all. So whoever can do that first can win, can be the end winner in a way, but also can solve the most challenges that people are experiencing. So without the emphasis of testing in cold weather environments, there's a really good possibility that we are left behind. I use the example of the American Disabilities Act was passed over, I think, 30 years ago. And I would ask you on your way home today or tomorrow, if you're out walking, see how many pedestrian curb ramps in your neighborhood or in where you're working are not compliant. It's 30 years and we're still not up to date on that. So if 30 years or tomorrow, fully automated vehicle in one community or one specific environment is deployed, it might be another 30, 50. How many years until we would get it to the next one?
Yeah, I'll just add that, you know, as we think about where do our fatal crashes occur, they tend to occur in rural parts of our state. And so I think, cold weather aside, all the infrastructure concerns that Tara is raising is really important, because this promise that we've all been sold, 15 years ago, that these automated vehicles are just 5 years down the road. And if we just wait 5 years, 93% of our crashes are going to be solved, because all these human behavior issues have been alleviated by automation. But if we're only able to operate these shuttles in low speed urban environments, where we have all the infrastructure and all the mapping, we're really leaving so many of our community members behind, and really not doing much to further our goals of zero deaths. So I think it's so important to be putting this type of pressure, that, why I would say a lot of investment has been stalled because of this promise, these over promises of automation. It's really important to just be pushing to say, no, like, does it actually work? Does it work in these domains and these domains? Because our goal is to stop these deaths. But if we have rose-colored glasses on, we're not achieving our goals.
Right. Based on what you observed, are there any infrastructure improvements that could enable vehicles to navigate the environment better, whether that's embedded sensors or other technologies?
I think that's an interesting question when you look at potentially the signal connectivity, and we were talking about the vehicle being able to communicate and understand what the signal phase and timing was. I'll note it wasn't always accurate, and sometimes there were gaps, disconnects, if we will, where it wasn't getting the signal. We weren't always able to figure out what the issue was. But one of our other pilot projects, the one that's ongoing up in Grand Rapids, Minnesota, Go Marty, doesn't use connectivity to the signals. It uses all camera-based to be able to read what the signals are, where it might see that one. And so I have a hard time saying, yes, we should make substantial investments in some of those things when you don't know what the technology is going to need tomorrow. And just because you might have a portion of industry utilizing something doesn't mean that that's going to be the thing 20 years from now. So from a mindful, conservative approach to invest in what's going to be valuable today, as well as what we hope is valuable tomorrow, is a little bit more where we're looking at going, but without going too far down that rabbit hole of making substantial investments that might not be beneficial.
All right. With that, according to our schedule, we're at the end of our time here, so I will move into, we always keep a couple minutes at the end for round robin. If anyone, not just our presenters, but although thank you to the presenters, any of our attendees today, if you have questions on any or comments on any current transportation, safety, and mobility issues that you or your organization are facing, and do you have any organizational, informational, or event updates to share? Or also, if you have any ideas for potential future council meetings, meeting topics, or speakers, this would be a great time to share that. So if you'd like to share, please use the raise hand feature, and you can share verbally, or you can add items to the chat.
Joe, I'll add one. I just wanted to note that Minnesota DOT is part of MaSTO, the Mid-Atlantic. I don't know what MaSTO stands for. I always get it wrong. Midwest Association of State Highway Transportation Officials, essentially the Midwest version of AASHTO. 10 states. We are hosting MaSTO in August, so the bigger event, but also we're hosting the MaSTO CAV Summit in June 16th through 18th. I can put a link in the chat here. And we're looking to try to get around 70 to 100 participants, with a focus being on state DOT goals with regards to problems with connected automated vehicles. And I know that we'll have some researchers from the University of Minnesota hopefully being able to showcase their research at our technology showcase, which will be on June 16th. But good opportunity if folks want to hear what's happening, not just in Minnesota, but other states around the region, and help try to solve some of those challenges.
That's a perfect update. Thank you. I don't see any other items popping in. So with that, we are right up against our 2:30 end time. So thank you again to Nicole and Tara for presenting today. And look forward to having you all join us at another one of these in the future. Thanks. Have a good afternoon, everyone.
Thanks
Thank you,
everyone for joining.
everyone. Bye-bye.